Type of solid injection that use single pump supplies fuel under high pressure to a fuel header. A. Common rail injection. B. Individual pump injection system. C. Distributor system. D. Single rail injection. Type of lubrication system in diesel engine in which oil from pump is carried to a separate storage tank outside the engine cylinder and used for high-capacity engine. A. Mist lubrication system. Wet sump lubrication. Splash system. D. Dry sump lubrication system. Produces extreme pressure differentials and violent gas vibration. A. Vibration. B. Detonation. Explosion. D. Knocking. Produces extreme pressure differentials and violent gas vibration. A. Vibration. B. Detonation. Explosion. D. Knocking. In a spark ignition engine, detonation occurs near the underscore 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 A. End of combustion. B. Middle combustion. Beginning of combustion. D. Beginning of interaction. In a compression ignition engine, the detonation occurs near the underscore 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 A. End of combustion. B. Middle of combustion. Beginning of combustion. D. Beginning of interaction. Morse test is used to measure the underscore 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 of multi-cylinder engine. A. Brake power. B. Indicated power. C. Friction powered. Motor power. Ignition delay can be minimized by adding underscore 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 to decrease engine knocking. A. Ethyl ether. B. Ethyl chloride. C. Ethyl nitrate. Ethyl oxide. At any point in fluid at rest, the pressure is the same in all directions. This principle is known as a Bernoulli principle. B. Archimedes' principle. C. Pascal's law. D. Torricelli's law. The hot wire manometer is used to measure pressure in gases. B. Pressure in fluids. C. Wind velocities at airports. Gas velocities. The pitot-static tube measures the static pressure ebb. The gauge pressure C. The total pressure D. The dynamic pressure. The terminal velocity of a small sphere setting in a viscous fluid varies as the first power of its diameter. B. Inverse of fluid viscosity. C. Inverse square of the diameter. D. Inverse of the diameter. Pressure drag results from a skin friction. B. Deformation drag. Breakdown of potential flow near the forward stagnation point. Occurrences of wake. The pressure coefficient is the ratio of pressure forces to a viscous forces. B. Inertia forces see gravity forces. D. Surface tension force answer, see crit. Which instruments is used to measure humidity of the atmosphere continuously, a barograph. B. Thermograph. C. Hydrograph. D. Thermohydrograph. Entrance losses between tank and pipe or losses through elbows, fittings and valves are generally expressed as a function of a kinetic energy. B. Pipe diameter. C. Friction factor. D. Volume flow rate. The air that contains no water vapor is called a zero air. B. Saturated air. C. Dry air. D. Humid air. In psychrometric chart, the constant enthalpy lines coincide with constant temperature lines at temperature above 50 cb, below 40 cc, below 50 cd, above 10 c. The amount of moisture in air depend on its pressure ebb, volume, temperature, humidity. The deep body temperature of healthy person is maintained constant at a 27 cb, 37 cc, 47 cd, 48 c. Air motion also plays important role in a surroundings. B. Cooling. Human comfort. None of these. During simple heating and cooling process has a underscore 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 humidity ratio. Increasing. B. Decreasing. Constant. None of these. The underscore 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 follows a line of constant wet bulb temperature on the psychrometric chart. A. Evaporative cooling process. B. Condensive cooling process. C. Direct cooling process. None of these. A vapor which is not about to condensate is called a mixture of vapor and liquid. B. Critical vapor. C. Superheated vapor. D. None of these. Passing from the solid phase directly into vapor phase is called a condensation. B. Fusion. Sublimation. None of these. Robert Boyle observed during his experiments with a vacuum chamber that the pressure of gases is inversely proportional to their temperature. Ebb. Pressure. Volume. None of these. Underscore 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 is energy in transit. Iona. Heat. Work. Powered. None of these. Is the mode of energy transfer between a solid surface and the adjacent liquid or gas which is in motion, and it involves combined effects of conduction and fluid motion. A. Conduction. B. Convection. Radiation. None of these. Radiation is usually considered a surface phenomenon. B. Surface interaction. Surface corrosion. None of these. Work is underscore 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 between the system and the surroundings. A. Work interaction. B. Energy interaction. Heat interaction. None of these. Is a process during which the system remains in equilibrium at all times. A. Quasi-equilibrium. Static equilibrium. C. Dynamic equilibrium. None of these. In the absence of any work interactions between a system and its surroundings, the amount of net heat transfer is equal to the change in total energy of a closed system. To heat and work. Energy interactions. None of these. The constant volume and constant pressure specific heats are identical for a compressible substance. B. Incompressible substance. C. Compressible gas. None of these. The velocity of fluid is zero at wall and maximum at the center because of the velocity effect. B. Viscous effect. C. Temperature effect. None of these. For steady flow devices, the volume of the control volume is a increase. B. Decrease. C. Constant. None of these. Work done in turbine is underscore 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 since it is done by the fluid. A. Positive. B. Negative. C. Zero. None of these. Power plant. Reheating process in Brayton cycle, the turbine work will increase. B. Decrease. C. Remains the same. D. None of these. Which of the following is the chemical formula of ethanol? A. C7H16B. C2H6O. C7H8D. C6H12. Which of the following is the chemical formula of heptane? A. C7H16B. C2H6O. C7H8D. C6H12. Which of the following is the chemical formula of hexane? A. C7H16B. C2H6O. C7H8D. C6H12. Which of the following is the chemical formula of toluene? A. C7H16B. C2H6O. C7H8D. C6H12. As the air passes through a nozzle, which of the following will increase? A. Temperature. B. Enthalpy. C. Internal energy. D. Mach number. As the air passes through a diffuser, which of the following will decrease? A. Temperature. B. Enthalpy. C. Internal energy. D. Mach number. As the air passes through a nozzle, which of the following will decrease? A. Temperature. B. Enthalpy. C. Internal energy. D. Mach number. As the air passes through a diffuser, which of the following will increase? A. Density. B. Entropy. C. Mach number. D. Velocity. As the air passes through a diffuser, which of the following will not be affected? A. Density. B. Entropy. C. Mach number. D. Velocity. After passing through a convergent-divergent nozzle, the density of air will A increase, B decrease, C remains the same, D. None of these. After passing through a convergent-divergent nozzle, the temperature of air will A increase, B decrease, C remains the same, D. None of these. After passing through a convergent-divergent nozzle, the Mach number of air will A increase, B decrease, C remains the same, D. None of these. By increasing the temperature source of Carnot cycle, which of the following will not be affected? A. Efficiency, B. Work, C. Heat added, D. Heat rejected. By decreasing the temperature source of Carnot cycle, which of the following will not be affected? A. Efficiency, B. Work, C. Heat added, D. Heat rejected. By superheating the refrigerant in vapor compression cycle with useful cooling, which of the following will increase? Use per unit mass analysis. A. Condenser pressure, B. Evaporator pressure, C. Quality after expansion, D. Heat rejected from condenser. By superheating the refrigerant in vapor compression cycle with useful cooling, which of the following will decrease? Use per unit mass analysis. A. Refrigerated effect, B. COP, C. Compressor power, D. Mass flow rate. By superheating the refrigerant in vapor compression cycle without useful cooling, which of the following will decrease? Use per unit mass analysis. A. Heat rejected, B. COP, C. Compressor power, D. Specific volume at suction. By superheating the refrigerant in vapor compression cycle without useful cooling, which of the following will increase? Use per unit mass analysis. A. Heat rejected, B. COP, C. Compressor power, D. Specific volume at suction. By superheating the refrigerant in vapor compression cycle without useful cooling, which of the following will not be affected? Use per unit mass analysis. A. Refrigerated effect, B. COP, C. Compressor power, D. Mass flow rate. By subcooling the refrigerant in vapor compression cycle at condenser exit, which of the following will increase? Use per unit mass analysis. A. Refrigerated effect, B. Specific volume at suction, C. Compressor power, D. Mass flow rate. By subcooling the refrigerant in vapor compression cycle at condenser exit, which of the following will decrease? Use per unit mass analysis. A. Refrigerated effect, B. Specific volume at suction, C. Compressor power, D. Mass flow rate. By increasing the vaporizing temperature in vapor compression cycle, which of the following will increase? Use per unit mass analysis. A. Mass flow rate, B. COPC. Specific volume at suction, D. Compressor work. By increasing the vaporizing temperature in vapor compression cycle, which of the following will decrease? Use per unit mass analysis. A. Refrigeration effect, B. COPC. Evaporator temperature, D. Temperature difference between evaporator and compressor. By increasing the condenser pressure in vapor compression cycle, which of the following will increase? Use per unit mass analysis. A. Moisture content after expansion, B. Compressor power, C. Heat rejected from condenser, D. Mass flow rate. If the pressure drop in the condenser increases in a vapor compression cycle, which of the following will increase? Use per unit mass analysis. A. Mass flow rate, B. Compressor power, C. Heat rejected in the condenser, D. Specific volume of suction. If the pressure drop in the condenser increases in a vapor compression cycle, which of the following will decrease? Use per unit mass analysis. A. Refrigeration effect, B. Mass flow rate, C. Heat rejected in the condenser, D. Compressor power. If the pressure drop in the condenser increases in a vapor compression cycle, which of the following will not be affected? Use per unit mass analysis. A. Compressor power, B. Mass flow rate, C. Heat rejection in the condenser, D. COP. If the pressure drop in the evaporator increases in a vapor compression cycle, which of the following will increase? Use per unit mass analysis. A. Refrigerating effect, B. Vaporizing temperature, C. Heat rejected in the condenser, D. COP. If the pressure drop in the evaporator increases in a vapor compression cycle, which of the following will decrease? Use per unit mass analysis. A. Specific volume at suction, B. Compressor power C. Heat rejected in the condenser D. COP. By lowering the condenser pressure in Rankine cycle, which of the following will decrease? Use per unit mass analysis, A. Pump work B. Turbine C. Heat rejected D. Cycle efficiency. By increasing the boiler pressure in Rankine cycle, which of the following will decrease? Use per unit mass analysis, A. Heat rejected B. Pump work C. Cycle efficiency D. Moisture. By superheating the steam to a higher temperature in Rankine cycle, which of the following will decrease? Use per unit mass analysis, A. Moisture content at the turbine exhaust B. Turbine work C. Heat added D. Heat rejected. By superheating the steam to a higher temperature in Rankine cycle, which of the following will increase? Use per unit mass analysis, A. Moisture content at the turbine exhaust B. Pump work C. Condenser pressured. Cycle efficiency answer. By reheating the steam before entering the second stage in Rankine cycle, which of the following will decrease? A. Turbine work B. Moisture content after expansion C. Heat added D. Heat rejected. When Rankine cycle is modified with regeneration, which of the following will increase? A. Turbine work B. Heat added C. Heat rejected D. Cycle efficiency. Is the combination of base load and peaking load. A. Rated load B. Intermediate load C. Combined load D. Overall load. Sum of the maximum demand over the simultaneous maximum demand. A. Use factor B. Capacity factor C. Demand factor D. Diversity factor. Regenerative with feed heating cycle with infinite number of feed water heaters, thus efficiency is equal to A. Otto cycle B. Stirling cycle C. Ericsson cycled. Carnot cycle. A type of turbine used in desalination of seawater. A. Back pressure turbine B. Pass out turbine C. Peaking turbine D. Reaction turbine. States that when conductor and magnetic field move relatively to each other, an electric voltage is induced in the conductor. A. Maxwell's law B. Kirchhoff's law C. Faraday's law D. Newton's law. Transfers heat directly to electrical energy by utilizing thermionic emissions. A. Thermionic motor B. Thermionic generator C. Thermionic converter D. Thermionic cell. Is the largest group of coal containing 46 to 86% of fixed carbon and 20 to 40% volatile matter. A. Anthracite B. Subanthracitic. Bituminous D. Subbituminous. When 1 gram of coal is subjected to a temperature of about 105 C for a period of 1 hour, the loss in weight of the sample gives the A. Volatile matter B. Ash C. Fixed carbon D. Moisture content. When 1 gram of sample of coal is placed in a crucible and heated 950 C and maintained at that temperature for 7 minutes, there is a loss in weight due to elimination of A. Volatile matter and moisture B. Ash C. Fixed carbon D. Moisture content. Consist of hydrogen and certain hydrogen-carbon compounds which can be removed from coal by heating. A. Moisture content B. Product of combustion C. Ash D. Volatile matter. By heating 1 gram of coal in an uncovered crucible until the coal is completely burned, the __ will form. A. Volatile matter and moisture B. Ash C. Fixed carbon D. Moisture content. Caking coal are used to produce coke by heating in a coke oven in the absence of __ with volatile matter driven off. A. Air B. Oil C. Oxygen D. Nitrogen. Grindability of standard coal ISA. 80B.90 C 100 D. 110. Major constituent of all natural gases ISA. Ethane B. Methane C. Propane D. Cethane. Two types of fans are acentrifugal and axial B. Reciprocating and axial C. Centrifugal and rotary D. tangential and rotary. Enthalpy of substance at specified state due to chemical composition. A. Enthalpy of reaction B. Enthalpy of combustion C. Enthalpy of formation D. Enthalpy of product. A type of boiler used for supercritical pressure operation. A. Lamont boiler B. Once through circulation boiler C. Force circulation boiler D. Natural circulation boiler. Economizer in a water tube boiler is heated by A. Electric furnace B. Electric current C. Incoming flue gas D. Outgoing flue gas. Receives heat partly by convection and partly by radiation. A. Radiant superheater B. D. Superheater C. Convective superheater D. Pendant superheater. Regenerative superheater is a storage type of heat exchangers have an energy storage medium called A. Matrix B. Regenerator C. Boiler D. Recuperator. Stirling cycle uses A as working fluids. A. Incompressible gas B. Incompressible fluids C. Compressible refrigerant D. Compressible fluids. In Stirling process, the heat is added during A. Isobaric process B. Isentropic process C. Isothermal process D. Heat process. Brayton cycle is known ASA. Carnot cycle B. Joule cycle C. Carnot cycle D. Rankine cycle. It is applied to propulsion of vehicle because of certain practical characteristics. A. Diesel cycle B. Otto cycle C. Carnot cycle D. Brayton cycle. Heat exchangers typically involve A. No work interaction B. No heat interaction C. No energy interaction D. None of these. A device that is used to convert the heat to work is called A. Adiabatic B. Regenerator C. Heat engines D. None of these. The objective of a heat pump is to maintain a heated space at a low temperature B. High temperature C. Medium temperature D. None of these. A device that violates the second law of thermodynamics is called a perpetual motion machine of second kind B. Perpetual motion machine of third kind C. Perpetual motion machine of the first kind D. None of these. A process is called if no irreversibilities occur outside the system boundaries during the process. A. Externally reversible B. Internally reversible C. Reversible D. None of these. An energy interaction which is not accompanied by entropy transfer ESA. Energy B. Heat C. Work D. None of these. A is used in aircraft engines and some automotive engine. In this method, a turbine driven by the exhaust gases is used to provide power to compressor or blower at the inlet. A. Discharging B. Turbocharging C. Supercharging D. Scavenging. The only device where the changes in kinetic energy are significant are the A. Compressor B. Pump C. Nozzles and diffusers D. None of these. The distance between TDC and BDC in which the piston can travel is the A. Right extreme position B. Displacement stroke C. Stroke of the engine D. Swept stroke. In compression engine, the combustion of air-fuel mixture is self-ignited as a result of compressing the mixture above its A. Self-developed temperature B. Mixing temperature C. Self-feed temperature D. Self-ignition temperature. The thermal efficiency of an ideal Otto cycle depends of the working fluid. A. The pressure ratio of the engine and the specific ratio B. The temperature ratio of the engine and the specific ratio C. The moles ratio of the engine and the specific heat ratio D. The compression ratio of the engine and the specific heat ratio. Using monoatomic gas, the thermal efficiency of Otto cycle A increases B. Decreases C. Remains constant D. None of these. In diesel engine, combustion process during combustion occurs during A. Isothermal process B. Constant pressure process C. Isentropic process D. Adiabatic. If the cutoff ratio decreases, the efficiency of diesel cycle A increases B. Decreases C. Remains constant D. None of these. If Ericsson cycle, the regeneration process occur during process. A. Constant volume B, constant temperature C, constant pressure D. None of these. In Brayton cycle, the _____ during constant pressure process. A. Work is added, B. Heat is transferred, C. Pressure is rejected, D. Energy is added. The two major application areas of gas turbine engines area. Driving automotive engine and locomotives, B. Heating and generation, C. Aircraft propulsion and electric power generation, D. None of these. The use of regenerator in is recommended only when the turbine exhaust temperature is higher than the compressor. A. Exit temperature, B. Inlet temperature, C. Mean temperature, D. Absolute temperature. As the number of stages is increased, the expansion process Beco-Mesa. Isentropic, B. Isothermal, C. Isometric, D. Polytropic. Aircraft gas turbines operate at higher pressure ratio, typically between A. 6 to 8, B. 12 to 24, C. 10 to 18, D. 10 to 25. The first commercial high-pass ratio engines has a bypass ratio OFA 1B3C 5D7. The single-stage expansion process of an ideal Brayton cycle without regeneration is replaced by a multistage expansion process with reheating between the same pressure limits. As a result of modification, thermal efficiency will A. increase, B. decrease, C. remain constant, D. None of these. Which of the following is / are the application of Brayton cycle? A. Propulsion system, B. Automotive turbine engines, C. Aircraft turbine engines, D. All of these. It used as working fluid in high temperature application of vapor cycle, A. Helium, B. Deuterium, C. Mercury, D. Water. The superheat vapor enters the turbine and expands isentropically and produces work by the rating shaft. The _______________ may drop during the process. A. Density, B. Viscosity of fuel, C. Temperature and pressure. None of these. Only ___________ of the turbine work output is required to operate the pump. A. 0.01%, B. 0.02%, C. 0.03%, D. 0.04%. Superheating the steam to higher temperature decreases the moisture content of the steam at the __________ A. Turbine inlet, B. Compression inlet, C. Compressor exit, D. Turbine exit. Regeneration also provides a convenient means of deaerating the feed water to prevent A. Boiler explosion, B. Boiler scale production, C. Boiler corrosion, D. Compressor damage. Can be applied in steam turbine cycle, Rankine, gas turbine cycle, Brayton, and combined cycle. A. Hydroelectric plant, B. Nuclear power plant, C. Cogeneration plant, D. Tidal power plant. In a Rankine cycle with fixed turbine inlet conditions, what is the effect of lowering the condenser pressure? The heat rejected will A. increase, B. decrease, C. remains the same, D. none of these. In an ideal Rankine cycle with fixed boiler and condenser pressures, what is the effect of superheating the steam to a higher temperature? The pump work input will A. increase, B. decrease, C. remains the same, D. none of these. How do the following quantities change when the simple ideal Rankine cycle is modified with the heat rejected? A. increase, B. decrease, C. remains the same, D. none of these. During a combustion process, the components which exist before the reaction are called A. reaction, B. combustion, C. reactants, D. product. In an obvious reason for incomplete combustion: A. insufficient carbon, B. insufficient air, C. insufficient nitrogen, D. insufficient oxygen. Higher heating value when H20 in the product of combustion is in a solid form, B. vapor form, C. gas form, D. liquid form. Device which transfer heat from low temperature medium to a higher temperature. 1 is A. adiabatic, B. refrigerator, C. heat exchanger, D. heat pump. A rule of thumb is that the COP improves by underscore 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 for each C the evaporating temperature is raised or the condensing temperature is lowered. A 2 to 4%, B 6 to 7%, C 1 to 5%, D 6 to 10%. Are generally more expensive to purchase and install than other heating systems, but they save money in the long run. A. Refrigerator, B adiabatic, C. Heat pumps, dehumidifier. The most widely used absorption system is the ammonia water system, where ammonia serves as a refrigerant and H20 as the cooling, B heating, C heating and cooling, D transport medium. The efficiency of all reversible heat engines operating between the same two reservoir underscore 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 A differ, B are the same, C are unequal, D none of the above. A process with no heat transfer is known as a isobaric process, B adiabatic process, C isothermal process, D isothermal process. The relative density of a substance is the ratio of its density of A mercury, B oil, C gas, D water. This type of heat exchanger allows fluids to flow at right angles to each other, A series flow, B parallel flow, C cross flow, D counterflow. The fact the total energy in any one energy system remains constant is called the principle of underscore 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 A conservation of energy, B second law of thermodynamics, C conservation of mass, D Zeroth law of thermodynamics. A process for which the inlet and outlet enthalpies are the same, E isenthalpic. Enthalpy conservation. Throttling. Steady state. The sum of energies of all the molecules in system, energies that appear in several complex forms. Kinetic energy. Internal energetic. External energy. Flow work. A system that is completely impervious to its surrounding. Neither mass nor energy cross its boundary. Open system. Closed system. Adiabatic system. Isolated system. A device used to measure small and moderate pressure difference. Manometer. Bourdon gauge. Barometer. Piezometer. A vapor having a temperature higher than the saturation temperature corresponding to its pressure. A superheated vapor. Saturated vapor. Supersaturated vapor. Subcooled vapor. The energy or stored capacity for performing work possessed by a moving body, by virtue of its momentum. A internal energy. Work. Gravitational potential energy. Kinetic energy. The thermodynamic process wherein temperature is constant and the change in internal energy is zero. Isobaric process. Isometric process, C isothermal process. Polytropic process. The function of a pump and compressor is to transfer heat from one fluid to another. Increase the total energy content of the flow. C extract energy from the fluid. Exchange heat to increase energy to the flow. This law states that all energy received as heat by a heat engine cannot be converted into mechanical work. A first law of thermodynamics. E second law of thermodynamics. Third law of thermodynamics. All of the above. The intensity of pressure that is measured above absolute zero is called a gauge pressure, EB. Absolute pressure, EC. Vacuum pressured. Saturation pressure. This is the ratio of the heat equivalent of the brake or useful horsepower developed by an engine and available on its crankshaft to the heat during the same time. Brake engine efficiency. Indicated thermal efficiency. Combined thermal efficiency. Brake thermal efficiency. Flow work is equal to pressure times underscore 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 a temperature, EB. Entropic. Internal energy. Specific volume. This form of energy is due to the position or elevation of the body. Internal energy. Kinetic energetic. Potential energy. Work. Another term for constant volume process. Isomptic. Isochromacy. Isovolumic. All of the above. Work done by the steam during a reversible adiabatic expansion process in the turbine. Brake work. Ideal work. Actual fluid work. Combine work. The efficiency of Carnot cycle depends upon the A pressure ebb. Entropic. Volumed. Temperature. Is the heat required in a constant pressure process to completely vaporize a unit mass of liquid at a given temperature ebb. Latent heat vaporization. Enthalpy of vaporization. All of the above. It is a commonly used device for measuring temperature differences or high temperatures. A thermistor. B. Thermocouplic. Bimetallic striped. Mercury in glass. The science and technology concerned with precisely measuring energy and enthalpy. Thermodynamics. B. Chemistric. Calorimetry. None of the above. The rate of doing work per unit time. A torque. B. Power. Forced. Moment. It an ideal Rankine cycle with fixed boiler and condenser pressure. What is the effect of superheating the steam to a higher temperature to the cycle thermal efficiency? A. The cycle thermal efficiency will increase. B. The cycle thermal efficiency will decrease. C. The cycle thermal efficiency will remain constant. None of the above. A vapor having a temperature higher than the saturation temperature corresponding to the existing pressure. Superheated vapor. B. Saturated vapor. C. Wet vapored. None of the above. It is the work done in pushing a fluid across a boundary, usually into or out a system. Mechanical work. B. Non-flow work. Flow work. Electrical work. A liquid that has a temperature lower than the saturation temperature corresponding to the existing pressure. A. Subcold liquid. B. Saturated liquid. C. Unsaturated liquid. Water. This type of boiler, the water passes through the tubes while the flue gases burn outside the tubes. Water column. Tricox. Gauge glass. D. All of the above. It prevents damage to the boiler by giving warning of low water. Safety valve. B. Fusible plug. Relief valve. Tricox. It has several functions. When necessary, it empties the boiler for cleaning, inspection, or repair. It blows out mud, scale, or sediment when the boiler is in operation and prevents excessive concentration of soluble impurities in the boiler. Blowdown line. B. Boiler feed water pump. Steam valve. None of the above. Is a feed water preheating and waste heat recovery device which utilizes the heat of the flue gas. Economizer. B. Open heater. Closed heatered. Water walls. It is a heat exchanger which utilizes the heat of the flue gases to preheat the air needed for combustion. Economizer. B. Feed water heater. Reheatered. Air preheater. It is a system of furnace cooling tubes which can extend the evaporative capacity of the water tube boiler and at the same time protect the furnace walls from high temperature. A. Reheater. B. Water walls. C. Superheated. Feed water heater. It is based on the generation of 34.5 lbm/hr of steam from water at 212 F and equivalent to 33,500 BTU/Hr. 1 HPB. 1 kWc. 1 boiler HPD. None of the above. It prevents boiler pressure from rising above a certain predetermined pressure by opening to allow excess steam to escape into the atmosphere when that point is reached, thus guarding against a possible expulsion through excessive pressure. A. Relief valve. B. Safety valve. C. Fusible plug. Pressure switches. In a water tube boiler, the water will pass through ________ A inside the tubes, B outside the tubesque. Inside the shelled. Outside the shell. It is the temperature to which the air becomes saturated at constant pressure. Dry bulb temperature. B. Wet bulb temperature. C. Dew point temperature. Saturation temperature. In a underscore 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 cooling tower, the air moves horizontally through the fills as the water moves downward. A. Cross flow. B. Counter flow. C. Parallel flowed. Double flow. It is the subject that deals with the behavior of moist air. Psychrometer. B. Psychrometric. Refrigeration. Pneumatics. It is the ration of the mass of water vapor in a certain volume of moist air at a given temperature to the mass of hot water in the same volume of saturated air at the same temperature. Humidity ratio. B. Specific humidity. Humidity. Relative humidity. Air whose condition is such that any decrease in temperature will result in condensation of water vapor into liquid. A. Saturated air. B. Unsaturated air. C. Saturated vapor. D. Moist air. It is the warm water temperature minus the cold water temperature leaving the cooling tower. Approach. Terminal difference. Cooling range. LMTD. The temperature where the relative humidity becomes 100% and where the water vapor starts to condense is known as underscore 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 a dry bulb temperature. EB. Dew point temperature. Wet bulb temperature. Saturated temperature. The surrounding air underscore 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 temperature is the lowest temperature to which water could possibly be cooled in a cooling tower. Dry bulb. Wet bulb. Dew point. Saturation temperature. Which is not a major part of the vapor compression system. A. Compressor. B. Condenser. Evaporator. D. Refrigerant. This refers to the rate of heat transfer attribute only to a change in dry bulb temperature. Sensible heating or cooling. B. Humidification. Dehumidification. Cooling and dehumidifying. It is a binary mixture of dry air and water vapor. Dry air. B. Saturated vapor. Moist air. D. Wet mixture. The temperature measured by an ordinary thermometer. Wet bulb temp. Dry bulb temp. Dew point temp. Wet bulb depression. The mass of water interspersed in each kilogram of dry air. Enthalpy. B. Humidity ratio. Specific volume. Relative humidity. This system combines two vapor compression units with the condenser of the low temperature system discharge its heat to the evaporator of the high temperature system. Cascade systems. B. Multistage system. C. Binary system. Multi-pressure system. A process of increasing the humidity ratio at constant dry bulb temperature. Dehumidifying process. B. Cooling process. C. Heating process. Humidifying process. The ratio of the partial pressure of water vapor in the air to the saturation pressure corresponding to the temperature of the air. Humidity ratio. B. Relative humidity. Specific humidity. Moisture content. In an air conditioning process that involves heating without changing the moisture content of air, the process is represented by a horizontal line in the psychrometric chart, from left to right. A. Sensible cooling process. B. Sensible heating process. C. Humidifying process. Heating and dehumidifying process. It is an air conditioning process of increasing the humidity ratio without changing the dry bulb temperature of air. The process is represented in the psychrometric chart by a vertical line, from up to down. A. Sensible cooling process. B. Sensible heating process. C. Humidifying process. Heating and dehumidifying process. The temperature at which the water vapor content of moist air begins to condense when air is cooled at constant pressure. Dew point temp. Wet bulb temp. Dry bulb temp. Condensing temp. It is the index of performance of a refrigeration system, which is a dimensionless quantity. A. Coefficient of performance. B. Energy ratio. Energy efficiency. Performance ratio. It is simply the compression of the gas in two or more cylinders in place of a single cylinder compressor. Intercooled compression. B. Multistage compression. Efficient compression. Performance compression. The transfer of energy from the more energetic into or more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between the particles. Heat transfer. Radiation. Conduction. Convection. What is the simultaneous control of temperature, humidity, air movement, and quantity of air in space? A. Refrigeration. Psychrometric. Air conditioning. Dehumidification. The non-condensing component of the moist air. Hydrogen. B. Water vapor. Nitrogen. Dry air. The substance used for heat transfer in a vapor compression refrigerating system. It picks up heat by evaporating at a low temperature and pressure and gives up this heat by condensing at a higher temperature and pressure. Water. Air. Ammoniad. Gas. What is the pressure of the refrigerant between the expansion valve and the intake of the compressor in a multi-pressure refrigeration system? A. High side pressure. Ebb. Discharge pressure. Condensing pressure. Low side pressure.